the autopilot on board?
Autopilot on board.
Because you guys are using your ground station for autopilot.
So the ground station, so the autopilot takes care of actually flying the plane. The autopilot just tells it where to go. So the plane is fully autonomous. If we on the computer set some flight points and say, you want to go to this flight point at 20 meters and go to this one at 40 meters, it will do everything automatically without me ever touching the controller.
So you upload a flight plan to that by your...
That's correct, that's correct. And the only reason we maintain the link is for the case when the flight plan has to be adjusted, because you don't want to land, plug something in every time you want to do it. And usually we do several autonomous missions per takeoff. So that's the reason we have that station. Any other questions? Carlos.
How much of the work you guys do, like when you're looking at this drone here?
Right. So
how much of it is like market available parts, and how much of it you have to do?
Okay. So this, as a project, it would be a systems integration project.
Yeah.
So everything you see in orange or blue, or well, this gray color, is custom designed, custom built in-house. So we 3D print these parts. The hexacopter is a combination of assemblies, and our job was to integrate them and make them work together. So you can't buy a drone like this, but you can buy individual components. Because that would be the answer.
So you buy the motors and...
in this case, yes, it was the frame, which is just the carbon, then the propulsion system with flight controllers, which comes as a separate piece, then the onboard computer that does image processing. Then inside there is an autopilot module, and there's a couple other things like this would be the GPS module here, and underneath there's a camera with a gimbal that we again designed ourselves. So these components are not made for each other, so we integrate them together. That's how I would describe that. Yeah.
Why hexa? Why not quad?
So the hexacopter is more stable. It can handle higher payloads for the same size, just with height. It can take a larger payload, and we rely on that because, well, not only our vision system will be mounted here, but also the object drop-off, which in our case is actually a water bottle, will be mounted here. So what is it, a 2.5 to 3 kilogram payload capacity on this? And the battery is not mounted. It's a massive 16,000 milliamp hour lithium cell. Well, that would be the reason.
I can add to that.
Absolutely. Yeah.
Another one is because of redundancy. So with a quad, if one of the motors fail, this thing will go down. With a hex, if one of the motors fail, it can still stay in stable flight, and then we can bring it down without any damage. So that's another reason to get a hex.
No better question would be, why not an octocopter?
And we're looking into that. We're facing we're reaching or we're touching the limitations of what this platform can do. So possibly in a few years' time, we might upgrade to more prompts.
What kind of camera is that under there?
On here right now is a 5 megapixel point gray machine vision camera. So I can probably tell you more about that, but our primary camera is a 12 megapixel point gray camera, which was in service following the crash.
Which model are you using?
This one is
Chameleon.
a Chameleon, and the other one is a Grasshopper 3.
I just came from there.
Oh, very interesting.
You didn't like the acquisition?
No, I was good with the acquisition.
If you're looking for animals or creatures, why not go with the something like a thermal imaging or?
We are looking into that, and we're
on the
negotiating
way.
sponsorship with Fluor, who acquired Point Grey, to get us a thermal imaging camera. So the only way we can get into that field is if somebody donates it to us because they're too much to afford. So the moment we get that, we get into the field.
Fluor was actually looking at integrating some thermal imaging with their current visual cameras, visible cameras now. So like I said, I literally just left there a few weeks back. So it looked like our camera. It was hard to tell from here. So
I think you can go with the germanium sensors on those cameras, and you can get a little bit of visible spectrum as well as the infrared spectrum on it.
Awesome. That'll be a question to sit. Anything else?
Or actually, gas is the...
No, we love talking about this, so ask away. We're
One more question. After the accident, any plans of adding an NTSB person on the team?
What is that?
Transportation Safety Board for all the cross-analysis?
Well, we have to do that because when you're flying autonomous vehicles, you have to be certified by Transportation Canada. So it's as if you have an airplane. That's the amount of certification we do. So we do crash reporting, and they essentially don't let us fly again until they analyze the crash report, and they say, okay, we think you've got to the root cause, and this will not happen again the same exact way. So there's a lot of documentation and just certification going into being able to do this. Yeah.
Transport Canada imposed a service ceiling limit on your drone.
Yes, I believe it's 500 feet.
400 feet.
400 feet. So we're not allowed to fly anywhere above that or outside of line of sight of either the pilot or spotters. So during competition, they let us go far away, but they have spotter people spread out through the area so that all vehicles are within sight at all times. Yeah, of course.
How do you calibrate your geolocating system? Do you have known ground targets that you reference and then calibrate your system?
Precisely. When we place those targets, I'll just go back actually. Well, that's a lot of slides. Right. When we place these on the ground, we record the position of where we place them. So then when we get a value from our georeferencing system, we can compare and evaluate how accurate they are. So currently, I think we're around the 1 meter accuracy with our current setup.
Do you have to do that for every mission that you do, or do you set that once at your lab and then you go out and operate?
We do it for every mission.
You get a 1 meter absolute accuracy from a GPS system?
Oh, the GPS system is only on the hexacopter. So we know the position of the hex, we know its orientation using an IMU, and then we do matrix transformations to obtain the coordinates of pixels.
Sure.
So that's why having a gimbal is important, because we try to keep it flat at all times.
Well, my phone doesn't even know which road I'm on, let alone 1 meter, so.
I guess the question was, how do you know the absolute location?
We're trusting Google Maps. Because Google Maps gives you up to, the thing is that 1 meter is what we got from the competition, because at the competition they had a 7th decimal place GPS location. They set up a ground control point, which they knew up to the 7th decimal, and we were able to use that to gauge our 1 meter accuracy. But in general, when we're just testing and stuff, Google Maps gives you up to the 6th decimal place, which translates to about 11 meters. And we meet the 6th when we're doing our work. So we know we're within 11 meters. And when we transition to RTK, we'll be going to within 10 centimeters because that GPS is differential. So we'll be within 10 centimeters of the differential between point A and point B. But point A, which is the base, will need to be known up to whatever accuracy we want. Because if that one is not accurate, then our rover, our plane, is going to be offset by the same amount. But that one will get us to within 10 centimeters. So that's something we're working on right now.
Of the absolute Google map. Because the Google map, you mentioned a number of decimal points, but
Yeah.
decimal points.
No, we wouldn't use Google Maps. We wouldn't use Google Maps to get our base location then. We would rely on some other survey grade GPS, which is, we can ask certain companies that we are in touch with. They have equipment that is millimeter accuracy, so we can ask them to set up a ground control point for us.
Yeah.
And once we know that point, we can always rely on that one point, because we've been in touch with local companies that do surveying, and they're willing to help us with that.
That's great. I had another question. Like when you showed the picture of your thing, trying to figure out if that was a snow goose or not. You know, the snow goose looked like same as a piece of snow. How does the software know the difference?
Okay. So it's part software, part people.
Yeah.
So what we do is assisted recognition. So we can't rely entirely on software because it's just absurd. Like, why not that piece of snow? But this one, we know it's a goose because prior to the competition, we knew what mock beast they were going to use, and we knew what they look like, so we knew what to look for.
Okay.
So it's
That was, of course, one of the competition challenges, right?
Yeah.
And
because I see that's like it's just a big block, right?
and there's also you're making the trade-off between how high up you fly, which means the higher you go, the shorter your flight will be,
Right.
And between how many pixels per target you get, right?
Sort.
Are you using any like movement-based recognition, or is it just static pictures? Like, do you recognize these snow geese by them moving, or?
No, it's entirely static. Yes.
It's a mock goose.
Yeah, these are mock geese.
Well, these are not real.
Yeah, they're not actual birds. They're what do we have it?
They would have flown.
Right here. Yeah. Yeah. The other problem with this is that we were expecting this during competition, because once you put a lot of mock geese in an area, actual geese tend to say, oh, my friends are there, so I'm going to land as well. So we were concerned about how that would impact our results, because we had to report every single pair of geese and the nest between them. But that ended up not being a problem even so. Yes?
So what kind of telemetry are you getting real time down to, or are you not? You just have to land and pull that data?
No, we're getting it continuously, and the absence of this very connection is what caused the plate to fly. We're getting position, airspeed, roll pitch, yaw of the entire plane.
Location, yeah.
Full location. What else?
Battery level?
Battery, yeah.
Battery
voltage, yeah.
And the images.
Well, yes, and the images continuously. Yes.
How much flight time do you get out the UAV, the hexacopter?
The hexacopter. So with the biggest battery we have, we're getting around 40 minutes.
And the fixed wing?
Fixed wing?
45.
45 minutes, yeah. So the way we designed this system is to have a trade-off between how much area we want to survey, and if it's a matter of area, we would use the fixed wing. But if it's a matter of versatility, say you have to survey and drop something, or you have to survey and pick up, then we would use the hexacopter.
Do you have a separate battery for the camera?
No, it's all powered from the same battery, and then we have just power conversion on board to step the voltage down. So I think the battery is, what is it, 6-cell lithium,
So it's
27 volts?
3.7 times 6, 24, 21 point something. I don't know.
So upwards of 20 volts, and then we have, I think, a 12-volt bus and a 5-volt bus to power everything on board.
Did you guys design the gimbal, or did you buy one off the shelf?
The gimbal is designed ourselves. The gimbal motors were purchased off the shelf, and the source code for controlling the gimbal was also taken from an open source project.
So you 3D printed the gimbal?
Yeah.
How well does it work? Pretty stable?
So far, so good.
Have you done video with it before?
We don't take video with this drone.
Have you tried it with video?
No, we've never taken video with this camera.
What is it? The one on the top is an antenna? Or?
This is the mounting point for the GPS, because it has to be above everything, and there's a battery here, so it has to stick out. Any more questions?
How far could you fly? I know you have rules, but how far could you fly away from your antenna or from your base station?
45 minutes, what's the top speed?
No, I mean like how before you lose contact. What's the radio link?
So there's several links. There was a diagram explaining that there's several connections. And so the RC connection for the remote would be the longest, and that would be probably in the order of 5 kilometers. The first link we would lose is the transmission of images, and that would occur somewhere, 1 kilometer, 1.5 kilometer?
I would say even more. If you have the tracking antenna pointed exactly at it, it would go almost RC level.
Okay.
Because
So that would be
it's a directed beam.
Yes.
Which, yeah, it's just a lot more powerful than previously we had an omnidirectional antenna. So that thing would work well without just we could just leave it in the corner and it'll work well within 500 meters. The main reason we changed to a directed antenna is because it gives us over 2 kilometers of range. Because we flew over 1 kilometer at the competition.
Much more.
Yeah.
And the Wi-Fi link is the image link is the one we expect to lose. So if that happens, we buffer the content, and then when connection resumes, we unload the get all the images.
How long has this project been going on?
So the team itself is 7 years old, but they started at the point where having a small plane fly was an achievement, and then it's progressed into autonomous flight, as in autonomous flight, then autonomous takeoff and landing, and now we're at full automation threshold. So on and off for 7 years.
So who's funding for the team?
Right. We rely on, and feel free to add to this, we rely on sponsors entirely. The school has sponsored us with a, I would say, insignificant amount for the first time in many years. So we accept discounts on equipment, donations, and donations from sponsors such as Alpha.
All the point grey cameras were given to us as a sponsor.
So we just received a very generous donation of the autopilot units that's inside there. We've got 3 of them from a company called Harris Aerial. So that was very generous.
What are the 2 carbons sticking out here for?
These guys are for mounting additional equipment. So on this side, they weren't trimmed because we don't know how much we want to mount. This is a LiDAR, which gives you a very accurate altitude measurement up to 40 meters. So this is used for landing, for automatic landing. So then this will tell you the actual altitude to whatever the ground object is, and then it will stabilize itself.
Do you have any plans to reduce the weight?
To reducing the weight. It hasn't. I would say it hasn't been a major issue yet. So the moment it becomes, we will look into that. The one issue that we had, and just clarifying this, is that because the payload is at the bottom, we moved the battery to the top, but we had to elevate it. You can see this orange platform, because the autopilot has to be in the very center of the hexacopter between all the motors. So raising the battery this high increased the center of mass, and with the biggest battery, for the long time it has been quite unstable. So we had to recalibrate the whole system specifically to handle this huge load. And when the battery is on, you tilt the hexacopter like this, and it flips over. That's how unstable it was. But because we have capacity in terms of power, our propulsion system, we can still handle that.
Or better off putting 2 smaller batteries on the feet.
Yes, that was another idea. The problem is you have to get 2 smaller batteries, which we don't have.
And correct me if I'm wrong, but I think this is the heaviest thing that's on there right now, or used to be on there, the delta manipulator. So the rest of the equipment is not as much of a concern. And now that we have this off, we can put more stuff in there.
What's the most that you've picked up with it so far? What's the maximum weight flown at?
Payload.
Payload plus
4.6.
4.6, yeah, I think.
4.6 kilograms.
total airframe weight.
Total
Yeah.
airframe weight, yes.
Takeoff. So this thing can take up to 4.8. That's the suggested maximum takeoff weight by the manufacturers of the propulsion system. So they say it's 800 grams per motor. But yeah, so we haven't exceeded that yet. I don't know if you have plans to.
I don't think we should, no.
Weightlifting competition.
And just to put that in perspective, the plane can lift up to 10 kilograms.
Yeah.
So that tiny thing can lift up half of the weight that the plane can.
Yeah. So the plane was designed to, instead of having a point gray camera, have a DSLR on a gimbal inside. So we never went that far.
What's the next plane that you're gonna build?
So both this and the fixed wing, and we actually have a redundancy for both of them. So the fixed wing we crashed, we already have a new frame, as well as for this we have an extra of each component. They were built this year for this competition year, so we expect to have them for
At least next year.
a year, hopefully too. We're very happy with how these systems are performing, and any issues we're facing are just a matter of tuning. Will that be accurate?
Yeah, so what happened was a couple of years ago, we revamped our system, got a new airframe, had a new system. We went to competition and did not do so well. But then for the competition the year after, we didn't change any of the actual physical system. It was more of the work, more work went into the imaging side and the software side. And we placed second across Canada that year. So we're expecting, again, this year we made a major upgrade to our system, changed the airframe, changed a lot of the software, went in with a lot of new stuff, and we found out we bit off more than we could chew this competition. Didn't do so well, but we were happy with the way the system performed. So for next year's competition, we're going to go in with the same physical system and going to put in a lot of work into the prep and the software and tailor it to the competition requirements without having to worry about the hardware. And we're hoping to perform well again next year.
But it's also, we have to mention that this competition was extremely challenging, not because of the conditions, which was 45-kilometer-an-hour gusts, and the couple of weeks preceding to that where it was raining in Vancouver and we couldn't fly. We had a time allocated for, we're doing a test flight every day, but it was pouring rain, we just couldn't go. And to put that into perspective, the competition was scored out of 100 points, and the team that won got 52. So the goal of egg pickup was not even attempted, and the challenge of geese classification identification in the conditions that we had in Alma, which is snow and wind, really a lot of teams did fairly poorly, or expected to do a lot better than they did.
You're graduating pretty soon.
That is correct.
I believe you're graduating pretty soon. I know you're there. So how's the next year's team looking like?
It's looking good. We do have some people staying. Actually, let's say about half the people who went to the competition, they're staying. And of course, we have a lot of people that are new in their first year and second year studies. And basically, we have team leads and we have people that are responsible for different submodules of the plane, of the aircraft. And basically, those people work with them and basically shadow them in their roles, so that once they, at some point, that they can take over.
We also put a very strict emphasis on documentation of everything we build and everything we do, with the hope that anybody who takes this on in the future, should I be gone in a month's time, will be able to understand what I did and why I did it, and it wouldn't stop development as much. But yes, we do have new members, and we're training a new pilot. So the team will go on.
What's the criteria for being in this team?
It's open to everyone. We welcome students from any program, any faculty. I do believe, well, we have even some people who are not SFU students who were some part of the team, but really just attendance, show up, do something, express interest. We've had several examples. Sometimes we would have 7 to 10 new people come in. They would come in once, twice, then they would leave. Some people would come in, be very ambitious, take on a lot of work, and then we would never see them again. But then there's some people, we had a first year who started this very year. He was on the flight crew, among the 5 people on the flight line dealing with the plane. So it varies.
Lawrence join?
No, I want to get rid of them.
No, and we welcome people. We have a lot of work to do, and even the tools and the resources to do that work, the limitation would be time. So if you have anybody you know who's in an engineering program who would like to join, please let us know. We'd be happy to have them on board, or at least come and see what we do. By the way, the flight test on the 19th, if any one of you or one you know would be interested in seeing how this whole thing works in a mission scenario. So we would come, we would say, this is the mission that we're attempting today, and then you would be there through the whole process of developing the flight plan, surveying the area, reporting back, probably an hour and a half total. We are hosting one in a month's time, so July 19th. Sorry, you had a question?
Does your system have any object detection or avoidance, say like a boost in the air?
Right. The object avoidance is done virtually. There's no actual objects. And it's done in a way that the competition that we're attempting right now implemented it. So there is a competition server, it's called that, we call it the interoperability server. And there is a model for obstacles and how they move around the airfield during flight time. So what we do is we poll this information, make an HTTP request, get that information, and then we adjust our flight plan to not be inside those obstacles at any point during the mission. So if our mission is, I don't know, this picture, the obstacle might go from the bottom left corner to the top right corner. And regardless of what we're doing inside, we'll never be in that area when the obstacle is there. So that's the extent to which we handle this problem. If you meant obstacle avoidance by seeing something and avoiding it, no. Like
Not yet.
power line, not, yeah, I would answer not yet because we might get there. You never know.
I have a reverse proposition here. So we will show interest, but next year's team, smart people like you join in, we want to meet them. Right, Andrey?
Absolutely. And it's fair to say that even, I think me and Sid both, we've decided for ourselves that the amount of work we put in, the amount of involvement we have in the team, we're not going to drop out. We'll still be there, you know, part-time as either advisors or come work occasionally. Because it really is a great atmosphere. A lot of people who joined the team never got to solder, with the exception of a couple of courses, until boom, suddenly you have a project to do. And things like this, these are all student developed. Somebody went and in SolidWorks did this whole design. And this didn't come immediately, there were iterations. Things like this cover was also built by us. Like somebody went and made a model and then printed. And this is the stuff they don't teach at the school. So having an opportunity to do this in a school environment. Sure.
Are you guys approaching this project in isolation, or are you contacting like existing avionics companies and seeing how they do things?
A little bit of both. So we're doing our own thing, but recently we've gotten an industry advisor. So there's a local company called 3 Points in Space Media.
Yeah.
They do similar work with a different client base. So they're doing a lot of coastline surveying. So we've gotten in touch with them and they've been good. They want to help us if you have any questions of getting out into the market, and if you want to see how they do their work and how does it work in a more commercial sense. Because we've never explored the idea of going commercial with this as of yet. So I think that's the extent to which we've contacted companies outside.
But just in terms of like your autopilot system and things, I mean, are you developing that from theoretical principles, or are you contacting Honeywell and seeing how they develop autopilots?
We're using an open source platform.
And this is one of the most popular open source platforms called APM, RDPilot, and it works on something called a Pixhawk. And lots of commercial applications do use Pixhawks as well. So it's almost an industry standard for autopilots for UAVs.
Okay.
Test field you mentioned?
The what?
Located?
Where is this? This is called a Renegade Field. It's in Surrey.
Yeah, 152nd, yeah.
Yeah, so there's an RC club, and they were very nice to let us, first of all, come with all our equipment and fly autonomously, which is a big one. And then they also let us fly rotary wings, which is usually not allowed in the field. So yeah, we're very thankful to them there. They're great. Okay, thank you very much. It was great talking to you all.